Hello again, this is Earth Science teacher Tim Martin, and in this video we want to go over the states of matter, particularly as they relate to water as we talk about water in the Earth's atmosphere. Let's jump right in. There are the three common states of matter: solid, liquid, and gas. Of course, there's also fun things like plasma and Bose-Einstein condensate, but we'll leave those for another day. In this case, the solid is represented by the beaker of ice, the liquid represented by the beaker of water, and the gas is filling the balloon. But we want to examine these a little more closely. We'll notice that all matter is made up of particles, in this case molecules of H2O. In the gas, the atoms are most dispersed. In the solid, they're networked together. Liquid, of course, is the most dense, so that's why we see more molecules in a smaller area. But we also want to talk about how they move around. The solid, because of the fact that the molecules are networked together, they may vibrate, but don't change position significantly. In a liquid, they're free to move about anywhere within the container that holds them. The gas, similarly, are free to move about anywhere in the container, but they move much more rapidly. These are important concepts that we'll explore a little more later on. Not only do we talk about the states of solid, liquid, and gas, we're interested in the transitions. Is it possible to go from solid to liquid or liquid to solid? How about liquid to gas or gas to liquid? Would it even be possible to go from solid to gas or a gas to solid? What are the names of these transitions and how do they work? Let's explore this a little deeper. First, let me step outside and light up my propane torch. Now, as I reach over and bring some ice, you can quickly see as I apply the heat or the fire from the propane torch to the ice transitions from solid to liquid very easily. So, in order to melt something, we need to add heat. In this next demonstration, using a time-lapse video, we can see liquid water becoming solid. In order to freeze something, going from liquid to solid, we need to remove the heat. How about liquid to gas? You can see here a beaker of liquid water is placed on a hot plate. As energy is added, the liquid water becomes water vapor. In order to evaporate, to go from liquid to gas, we add heat. Those of you who live in a warm, humid climate are familiar with this next transition, water vapor to liquid water. On the outside of a cold drink, you can observe condensation. Water vapor from the air condenses and forms liquid water on the outside of the container. We know this is not coming from within the container because the water level in the container does not drop. In order for condensation to happen, we need to once again remove heat. For this next transition, I wanted to start with something a little more dramatic. At nearly 80 degrees below 0 Celsius, this is solid carbon dioxide. It passes directly from solid to gas. This sublimation is why it's sometimes referred to as dry ice, because it doesn't melt, passing directly from solid to gas. You can see with these small chips that I've sprinkled on the table, they gradually dissipate, leaving nothing behind. Sublimation is the process of going directly from solid into gas. Beyond the solid carbon dioxide, we can see this also with water. It just takes more time. On the upper left is an ice cube, the same ice cube several days later. You may notice this in your refrigerator, but let's just take a look at this. If I take a look at the size of the initial ice cube and move that down to the lower image, you can see that the lower image indicates that the ice cube has in fact reduced in size significantly. This is not because the ice cube melted. This ice cube was kept in a freezer and the ice transitioned directly from solid to gas through the process of sublimation. In order for something to sublimate, we must add heat. Deposition is the final one of our transitions. In this case, water vapor from the air is depositing as ice crystals on a refrigerated bolt. Let's watch that time lapse again. These still images help us see a little better the top bolt right as it came out of the cold environment, and the lower one after ice was deposited on its surface. In order for deposition to happen, we must remove heat. These 6 transitions are vitally important to understand the process of how water moves around in the Earth's atmosphere, and we'll discuss them in much more detail. In our next video, we'll specifically look at water in the Earth's atmosphere. Thanks for watching, and have a great day.